Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, Stewart is ready. I think it's going to help you to digest food better. And there's extra dessert in the back. Stewart Tansley is one of my dear coworkers and who's been buried by the success of Kinect. And we're grateful that he's here. And please get rid of my guilty feelings about taking over their lunchtime. Do something that impress them.
Jan is just great for the pressure, right? Well, good afternoon, everybody. I hope you're enjoying lunch. I'm not, because I'm not eating, but I will try and make your lunch more pleasurable. I think helping you digest it might be a little hard. But so as it says up there, I'm Stewart Tansley. I'm responsible for NUI in the Microsoft Research Connections group here at Microsoft Research. And I think you've received a presentation of the overview of what Microsoft Research Connections does. And I know there are many, many presentations peppered throughout this nice event from different people representing different parts of the group. And today, or rather for now, for lunch, it's about NUI. And hopefully some of you know what NUI is, Natural User Interface or interfaces. You hopefully will learn if you don't know what that NUI is. This is an hour slot, I think, but I'm certainly not going to talk for an hour. Don't worry about that. You will have time to relax. So it'll just be a quick taste of the world of NUI and scientists. So this event is all about data, and a lot about what NUI is thinking about today is driven by data, and we think can help with data. So I just flagged this up to say we're on the same page. We think that NUI can help with a lot of the data processing process in research. Because so much of data that's around is really helping to drive research today. And there are numerous articles on this. You've read them too. Some of them we've participated in. But natural user interfaces is very much part of this world in a way. The sensors that are generating all that data for scientists today, for you folks, those very same sensors are actually, because of the economics of those sensors, the power of software applied to the data coming from those sensors, that's proving really useful to help us in our interaction with that data via new user interfaces. The data that's around, therefore, is really synergistic with natural user interfaces. NUI today, natural user interface research, and where we're at in Microsoft Research, especially Microsoft Research Connections, we're thinking about how to rethink the ways that people interact with data, how to interact with the technology that they're using to process data. We're reevaluating everything from the non-physical design to the human needs, the human interaction needs, looking at the whole kit and caboodle. We think that NUI can potentially revolutionize the way we think about technology, and that goes for data-driven science too, as much as the rest of the fields, some of which you've already seen, no doubt. Kinect is a big part of this, but you'll see a lot of Kinect in my talk today. Kinect is just a great, very in-your-face exemplar of NUI. It's not the whole story about NUI, but it's one of the most accessible ways you can get into using NUI yourselves in your own problem spaces. I even have a box with that's our product, our new product, Kinect for Windows. You've heard about Kinect for Xbox. Well, now you can program Kinect on a regular Windows PC, and I'll say some more about this. 3 takeaways today. I want to tell you where we are with NUI in product. The box is it. I'll say a little bit more, though. I want to tell you about NUI in research, a little bit about where Microsoft Research Connections is particularly facilitating that for the science community. And last but not least, the community itself. You are part of that community. One of the things I hope to invite you to participate is in NUI in community, in the science community. My bonus takeaway, yes, there's more, is my email address. Not every presenter gives away their email address, but I'll risk it with you. We're amongst friends here, I think. I'm really looking for your feedback and what you're seeing in the community, in the science community, in data-driven science, about how NUI is being used today or how NUI could be used. So without further ado, let's go. Kinect for Windows product. Not the only NUI product in town, but certainly one of the things that's most excited the community of so many different types of people. Originally designed as a novel user interface for gaming, but of course it has a much broader potential. We recognize that too. And last year we spent a lot of time, myself included, in helping to get this product available, where now Kinect for Windows is available for everybody to program on their regular Windows PC. Go to this website. This has got all the information you need. It is a fully supported Microsoft product today. There's no Microsoft research behind this. There's nothing flaky about this. Version 1 came out in February this year, 1.0. And in fact, there's already a V1.1, and they'll see further updates, because these guys are fast-tracking themselves. This is a new product team, but they recognize the agility required in technologies like this is much faster than the tends to be slower product cycles that Microsoft's been on in the past. So you'll see cycle times within months rather than years on this product. The hardware looks a bit like the Xbox product, you'll see, but it's slightly different, and it's already paving the way for new features that are not going into the Xbox version. The Xbox version fits a regular-sized living room. It's for multiple players playing a game or other interactive experiences in the home. But this needs to be a bit more flexible. And one of the main differentiators, for example, right out of the gate, is on a PC, the user experience is generally a lot closer than in an Xbox scenario, where in Xbox, I'm in a living room, I'm standing, maybe with my friends or my family, and I'm dancing in front of the screen, making an idiot of myself and having fun. Hopefully you'll do that on Windows too. But with this, maybe you're sitting in front of a PC, which is a different experience from the 10-foot user experience in a living room situation. Here, I might be seated at a desktop, and I still want to do some touchless gesture user interfaces through Kinect, or use the audio interface. It's got a really great microphone array in it. Then I'm sitting in front of a desktop. That requires a different style of experience, and the sensor is tuned for that nearer capability. It has a near mode for those that want to drill into it a little further. I want to keep this talk short. You want to eat, or you want to digest, and you want to converse. So go to this website for the full details on this product. I will flag that there is an academic discount available in the US only at the moment. It is coming for the rest of the world. We are working as a company as fast as possible to get it available for the rest of the world. We had a quick way to get it academic discount for the US, but the rest of the world, it's available. It's available in retail. It's available through other channels, also described on this site. The academic discount is just temporarily US only. And it's the same price as the Xbox system for academics. I didn't want to leave it there. I think that I would like to leave you with some thoughts for Kinect for Windows with this video. You may have seen this video before, but let's just take a couple of minutes to look at this, because I think it's a rather sweet video.
Play.
We thought this would be fun to play with, and it was. But something amazing is happening. The world is starting to imagine things we hadn't even thought of. Unexpected things. Helpful things. Beautiful things. Inspired things. Which is why, even though the world keeps asking us what we'll do with Kinect next, we're just as excited to ask the world the same thing.
So it really is over to you now. Not this moment, but have a think about what you can do with Kinect in your worlds, back home in your offices and your labs. We are building the platform side of this. We're not focused so much on the applications today. We are looking at applications within the entertainment world, in Xbox and so on. But in science, it really is together we can empower you with a software development kit and a sensor for scientists, for any programmers. And it's really over to you to show us what you can do, show your own community what you can do with this technology. Let's go back to the deck. One of the things that Microsoft Research Connections does, working with you good folks, is we can take some of the new technologies that are emerging out of Microsoft Research and help get them out into the world, into the research world particularly faster than otherwise the rest of the company can do. Kinect actually was an example of that, where we've really helped accelerate the software development kit being available for Windows. But there's more to come. And these research accelerators, as we call them, from Microsoft Research Connection, represent a whole catalog of different types of technology that we are putting in your hands to help you do your research more quickly. Next up in the world of NUI and Kinect is something called Kinect Fusion. How many of you heard about Kinect Fusion? You? Okay. Not so many though, so let me show you a video. That'll be a quick way to tell you about Fusion.
Hi, my name's Sharam Azadi. I'm a researcher from Microsoft Research Cambridge in the UK. Today I'm going to present to you Digitize Your World. It's a really cool technology that makes Kinect cameras really come alive, allowing you to scan in 3D models, 3D geometry of your entire room very quickly in real time, just using this cheap Kinect camera and some clever software. So I'm going to jump straight into a demo. Here we have a Kinect camera. And behind me, we have the 3D model that's generated as we're moving this Kinect camera within our space and scanning in the 3D geometry. So in front of us, we have a coffee table with various objects on it. And you can see this high-quality 3D model is being generated in real time and updated in real time. So for example, if I move up close to the keys on the phone, you can actually start to see that detail on the 3D model behind us. Or if I actually move the fruit bowl out of the scene, you can see it fade away. And it's not just a 3D model of of objects within the space. It's actually a 3D model of the entire space. So if I actually pull back, you can see we're generating a 3D model of a large area of the space. So for example, we're actually capturing the keys on the keyboard or the monitor. Another example might be 3D scanning a person. So if my colleague actually walks in, behind us we can see a 3D model being generated in real time of him, and we can actually see that we can capture details such as smile or facial expressions, right down to the wrinkles on his shirt. So we're really excited about the possibilities that this technology enables. One might be new types of gaming scenarios, where you can scan in physical objects and have them within the digital game. So imagine being able to scan in a skateboard and have that appear within the game. Or even scan in your whole body and have you as the Xbox avatar. So this is really about bringing the physical to the digital.
And bringing the physical to the digital is a lot about what we're doing in our research in NUI today, and then using NUI technologies like the Kinect device and software on top of it to do Kinect Fusion, making smearing the gap between the physical and virtual worlds. This technology is in the lab today. It was published in a paper last year, a couple of papers in fact, one best paper at one of the conferences. Clearly, a lot of people are interested in this technology because the differentiator is, while you might have seen a few hacks on the web that can do this with Kinect, you can't get it in as a real-time performance and as precise and with as much information, as much resolution as we can do on the GPU, which is where this code is running with this platform. We are trying to get this in the hands of you as soon as possible. Primarily, it is for research purposes at the moment. But clearly, the mind boggles with the potential for this kind of technology. If you can scan the physical world, this is like a 3D fax machine. I can scan a physical 3D object, and I can put that in the computer. I could reconstruct that object. It's not going to be a living, breathing object. We're not inventing the Star Trek transporter. But once I've got that model in the computer, I can do almost anything with it. One of the things that we know that scientists would love to do is measure things, just physically measure things. Today, people in agriculture, for example, with plants, they want to measure the growth patterns of plants. They're either having to get literally tape measures out and measure these things, or buy a really high-end laser scanner type device at tens of thousands or more dollars. I can do that type of thing with some software and a $150 device today in the coming months. And there's simply just an amazing number of scenarios where you can scan a physical object very cheaply and very quickly in real time, get it into the computer, get it into a CAD program or any other sort of graphics package. I can do an amazing amount with that. So look for that as soon as we can. Showing you the video. Third thing, community. Over to you. NUI for Scientists, I think, is a nascent community in interactive data visualization in particular. At the panel at eScience 2011, if you go and look at the archives of that, there's a link in this deck. You'll have access to this deck. I posed these questions to the panelists. I would like to pose those questions to you today, now. You don't have to answer right now. That's why I put up my email address. You can mail me your answers. I'd love to hear from you what you think about NUI and science. And part of my reasons just coming to talk to you today, to bother you with this, interrupt your lunch, is for you to mail me your thoughts on these questions. So please have a think. I'd really welcome that. Together, I think we can build a community around this thinking in NUI to share best practices of how people are using Kinect and other NUI technologies like touch devices, the multimodal interfaces where I have speech working together with touch, working together with touchless. Different times, different places for using those different modes of interaction. This is all NUI. How are we doing that in science? How would we like to do that in science? How could it help science to do those sorts of things? So my 3 takeaways, remember. I've shown you some NUI in product, the Kinect for Windows device. If you've not looked at that, you should. Check it out. It's a great weekend project. Buy yourself a Kinect. Do some Kinect hacking on it. It's a fun project. You can join this very worldwide community of people playing with Kinect technology, exploring what it can do. But also spend some time in the office, please, and in the lab. What can it do in your scientific applications? We'd love to see you do that. We'd love to put you in the next video, the next Kinect effect video, as we call it. Show your scenario in the video. NUI in research, well, Kinect Fusion's one of the things I'm signposting is coming down the pike. We'll get it to you as soon as possible. It won't take that long, we hope. We are writing code as we speak. And then the NUI community. You are part of this community. I invite you to be part of this community. Interactive data visualization is a phenomenal opportunity for new, novel user interfaces, as well as using these sensors, these same sensors, to get data and generate all this big data. What do we do with it when we got it? How do we navigate it? How do we browse it? How do we interact with it? I'd love to hear your thoughts on that matter. So please mail me, stansley@microsoft.com. That's all I have to say today. Thank you for your time today. Thank you. I'm here for a while for questions if there are any questions. Yes. Do you want to use the microphone? Are you going to use microphones for? Not on the recording. What is the price? The educational price for Kinect for Windows? $150.
Oh, that's a good deal.
Count them. It's the same price as the Xbox Kinect.
So if you come up with really good scenarios of use it, I have a couple of them that you can borrow for now. But it has to be good scenarios.
Can you winterize it?
Can you winterize it? Have a go. some epoxy, pot it, try it. We'd love to hear.
Anyone? So how many of you actually play games at home?
Because that's the gaming community, not the science community.
Right. But then do you dream to use something like this for your science? Dream to use something like this? Yes, you do. Yes. After Jonathan showed you, right? Yeah, you've seen that one, right? Yeah, when he stood there saying, go to your solar system. That's all it takes, and then you can go to your solar system. So you see that. But we, Stuart and I, myself here, really want to hear your ideas. And so either now or afterwards, email us. But if you have any comments or anything at all, share. Yeah.
Have you had any applications with using multiple Kinects, looking at the same space?
Yes, the product today supports, I think it's four simultaneous Kinects. There are some caveats on that. Each one maxes out a USB 2 channel. And so you need enough controllers in your PC to handle that degree of bandwidth. So you may need 4 separate USB controllers. That's typically not an off-the-shelf configuration.
And is the limitation the way the sensors work?
The amount of data that's putting out. It's the amount of data it's putting out. It's like putting 4 webcams. It's like putting 8 webcams. If you had 4 sensors, on here there's an RGB camera, there's a depth camera, and there's a microphone array, 4-element microphone array. So there are a number of caveats. So I'm talking about the channel caveat. Another one is that the way that this technology works, structured light, it's projecting an infrared pattern, which is then sensed by the camera to do the depth part of it. That light ultimately will interfere, and so there's a degradation of performance of the depth capability of the sensor with the more sensors that you have in the scene, in fact, the more projectors you have in the scene, because the depth camera has a projector and it has a camera. So it depends on your physical configuration. It depends on the properties of the materials in the room. But you can. We found that a couple of cameras works great together. There's no visible degradation there. But once you get 3, 4, then you start to flood the scene. You get less performance. Some people are trying linear arrays. So you can imagine putting a row of these things and having people traverse past them, or you get a breadth. And so that's another way to use this capability of multiple sensors, not all just flood in a single space, but having a linear array or another kind of topology. Good question. Yes, question in the back.
Here.
What is the accuracy of if you were going to use it to measure a plant?
What is the precision of the? So I'm just I'm recycling my physics indoctrination. Precision. So it's in research right now, but we're getting about 1 millimeter precision with the latest code. Don't quote me on that until we release the software, but it's of that order. It does vary though also on the texture of the material, because the way the structured light is working, you're inherently working on the IR reflectivity of the material, and so that precision will vary according to the actual material. What we're trying to do is look at a general purpose capability, but separately have a look at various specific scientific applications, such as measuring the size of plants to do growth rate measurement. And I think there is a general capability, but it's impossible to imagine just a general purpose scanner. I think that probably doesn't make a lot of sense. General purpose function that you can call an API, that would be useful. But there may be a specific application required for a plant scientist, for example. But we're exploring that. We don't have access. I mean, it is our hardware, but we are not calling upon the hardware in the device to get to that low level of information. There's other sorts of things you can conjecture here. It's using IR, so could we actually use the IR reflectivity to give us maybe biological information? Biological, it could be another measure. You know, we're thinking about this, but the way I would suggest to best think about this is not get overly focused on just this sensor. It's only $150. You could throw in a whole bunch of other sensors to augment what this is giving you. Just consider this a depth sensor together with its other cameras. But there's no need to overload what you're trying to use its technology for, because it's just $150. Put some other sensors in the scene if you want to measure other properties of what you're measuring. That's my recommendation. Yeah, question in the front. Yeah, it was about 0.8 meters was the nearest. What was the original one, going out to about I think it was 10, 12 feet. The near mode gives you a mode where I can now look between 0.4 meters and 0.8 meters. So it's a considerable. Yes, it's essentially a mode. It's a toggleable. So when you write your code, you switch the thing into the mode. I don't think there's any significant switching time, but you are in a different mode. It is a moded capability. It's not a continuum. Yeah, it's a good question. To the best of my knowledge, we don't provide that in our code, in our SDK. But I may be wrong on that. I'd have to check that for you, I'm afraid. I'm not sure, but I don't think it's there. The way that we do it is we do threshold at 0.4. Certain other folks like a more graceful degradation. It's a philosophical difference, but with our hardware and our software, we have a cutoff at 0.4 meters. Our philosophy is just that gives you a guarantee. You know where you are. And the primary scenario that we have in mind for this is still the user interface, rather than using it as a camera or a special sort of camera. But I think that this is sort of arguable. But we, in our SDK, threshold it at 0.4 meters. Question at the back. So I understand the gist of what you're saying, I think, in terms of compatibility between what we're doing and some existing geospatial stuff that you're using. Yeah. So as a side effect of our work looking at the general purpose fusion capability, Kinect fusion capability, together with specific scientific applications, the two-track work, we are looking at that to make sure that our specific applications work is obviously compatible with what people are already using in the field. And we would love to work together with the community on that. We're tackling a very small number of application scenarios. I would certainly love to hear more about some other scenarios we may not be looking at. Definitely geospatial is one of those. Yeah, but please contact me offline. I would love to hear more to sanity check what we're already doing, or perhaps extend what we're doing. It's really important that we don't come up with something unique and special and proprietary. That's crazy talk. We don't want to go there.
So we wanted to do the collaborations for some specific uses rather than as released as a general part of our original product. So then for each different communities, we want to hear from you. You're the experts who know what geospatial kind of accuracy or precision that's required, and then we can produce some extensions to this SDK.
Another question. I just told you what the next step is. You weren't listening. Kinect Fusion is the next step. For research. For research, Kinect Fusion is what Microsoft Research Connections is looking at. I mean, you can imagine all sorts of things. I've seen a lot of there's been some weird theories about like Kinect version 2 and these sorts of things. It's been very odd theories out there. I would manage your expectations on revisions to the hardware. I think the point about winterizing and having different physical form factors is really important for us commercially, and really important for us as scientists too. But even that is still, it's going to take a little time. This software is being fast-tracked. But the hardware will be on a slower cycle. One of the things that you should think about is that this sort of technology, well, we're all familiar with Moore's Law, and we've already enjoyed Moore's Law. This technology barely works today. It's amazing that it works. I sometimes, when I do a general Kinect talk, I introduce the M word. I introduce magic. This is working, barely working. It's at the physical limits of what you can do today. It was not possible 2 years ago to have a consumer product do this. And so we're already at the outer limits of technological capability. Don't expect too many grand advances or double the resolution or wireless mode. If you can hack a wireless mode, go for it. USB 2 bandwidth you need. You could, I guess, have a. I don't know what the state of the art in wireless USB is today, but if they've got to USB 2 capability, I know there's certainly USB 1.1 in wireless USB. We can get to wireless for USB 2. I'd be very interested in that because I could imagine it would make the device very interesting in scientific scenarios. So please do some investigations. We'd love to hear. Another question, yeah. 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 I understand where you're going. So the question is about, making. Can we use a phone-type platform work with this kind of device? I mean, this device is fairly bulky, and I'm saying as to the other gentleman that I wouldn't expect too many changes to the form factors of this over a short period at least. It needs a lot of power, and so and Kinect Fusion needs a lot of power too. This runs on a GPU. In fact, it runs on 2 high-end GPU cards today, which is why I'm not demonstrating it live. I'd love to demonstrate it live. We're still trying to get our PC together with 2 GPUs. But and it's a desktop machine, not a laptop. So I think while we could talk a lot longer at that, and I'd be happy to offline. Save everybody else listening. I think there are other reasons that would get in the way. So portability would be nice, but it's not a strong driver at the moment. We're actually more looking at the higher end software, needs a fair amount of hardware underneath, and not so worried about the phone. It's not a practical form factor for the phone today. This particular type of technology that's making Kinect hardware work, not so much the software, but the hardware, doesn't work in small form factors. You need other types of technology, for example, to do depth cameras using other ways than what this uses. Again, I'd be happy to go talk more about this another time. Should we wrap that up today? Yes. Thank you very much for questions. Some good questions there. Appreciate it.
Thank you again.
And remember my email address, NUI in Science. Please tell me more. Would love to consider you folks as part of that community. So please send me an email. Thanks.
So the next one is Layerscape again. If you want to take 10 minutes and just, get more coffee or more dessert, and then you're welcome to do so while Rob set it up. Good. So back to Layerscape, and Rob needs no further introduction.
Okay, thanks. Is the it sounds like I'm live there. We'll do that. We'll go back to here. So when last we left our story on the Layerscape Worldwide Telescope side of things, I was showing a second demonstration that had 6 different types of data in it, and I got about halfway through that. So I thought I would just sort of let's see, play the rest of that tour before launching into a bunch of mechanics. So this is going to be a little bit deeper dive into the details of how to use the Worldwide Telescope in the Layerscape environment. And I'll remind you that this is a map overlay, a map draping, and I'll show how to do this in detail. But I'll remind you that Layerscape is our sort of earth science branding of the Worldwide Telescope visualization engine and the tools associated with that. That's the website and the Excel add-in. Now there's a sort of a fourth piece of the story, which is that the Worldwide Telescope application has an API that you can also make use of. So I'll take some time in this next 55 minutes or less to go over some of the nuts and bolts of how that API works. And if you're familiar with a RESTful interface, it's sort of pseudo-RESTful in the sense that you are essentially doing a print statement to a port on your computer, and that print statement is a bunch of text that you're formatting, and that contains both commands to Worldwide Telescope and then also data. And this thing is a tour that's actually playing, but it's paused, but now it just ran out of time. So that's an example of sort of messing around with the way a tour is authored so that you can build in pauses and go and manipulate and so forth. Let's see. So this is being jerkier than it was yesterday, and it may be because the laptop was not plugged in for a minute, and so it's sort of waking up the GPU. So we'll hope that that jerkiness goes away. But in any case, the point here is this is 700,000 data points. It's a little bit smoother now. And this is imported using the Excel add-in, I think. And in this case, with the data set, this is data set number 3 out of 6. And this is a high-resolution bathymetric survey. So again, it's showing that Worldwide Telescope has the capacity for at least a moderate amount of data, not a gigantic, billion pieces of data, but sort of 500,000 is perfectly reasonable. And you'll have to forgive the performance hit from the laptop through the projector and all that kind of stuff. You see that map passing by that was in the Pacific Northwest? All right, I'm going to take a minute and sort of restart things here. Okay, so I'm using the search engine here to find some content, and the idea is that the content is a PowerPoint slide, a couple of PowerPoint slides. This is very frustrating. that is slow. Okay. All right, then. Skipping ahead still further. Using Layerscape, I had it pointed out to me earlier that the relationships here for 3 different components of Layerscape are fairly complicated, so it would be a good thing to do to sort of go through it. So that's what I'll do in this short deck. And then I want to talk about the map overlay idea and the availability of a tool called Map Cruncher, which handles projections that aren't necessarily the same as the Worldwide Telescope of Spherical Mercator. I'm going to talk about the How to Get Started tutorial that's a resource that's available at the Layerscape website. And what that is a PowerPoint deck like this that you can walk through step by step. And then the last thing I'll talk about is the API, which is, as I mentioned, is sort of a semi-RESTful interface. And I'll sort of get down into the code without too much detail, but hopefully enough to get you a sense of how you'd go about writing against the API. So, without further ado, let's go down. Let's see, page down. How's that work? So, the way that Layerscape works is that you have these 3 different components, which is the website, the Worldwide Telescope client, and the Excel add-in. And the idea is that you would then go to the website, you would learn about how Layerscape works, you would install Worldwide Telescope on your PC, and from there, you would start using the Layerscape website to look at content and find out what's possible, what's available, and then go from there. Oh, yeah. Okay, sorry, I have to fix this, too. Good grief. All right, we're off and running again. So here we have you, or me, a researcher, and starting off with your computer, and we're going to build up the Layerscape picture from here as a sort of a narrative of how you would go from one step to another. So the first thing you do is you go to the website, and there's the website title up at the top, and some of the drop-down menus, and then there's featured content, which is over on the left-hand side, and I've shown that tour there that I showed yesterday. So we want to imagine that we've gone to that website, and then what do we do? Well, the first thing would be, if we're ready to go, we can install the Worldwide Telescope client using that orange button up there. And then so what happens as a result of installing is that you get Worldwide Telescope running on your PC down in the lower left here. And that's got all this interesting content available for it. So, of course, you start looking around in the Layerscape website for that content. And in particular, each icon below it, there's a blue button that says View Tour. You click on that, and that sends down the data in the tour, and that's a combination of the cinematography and the data itself, so that when you have that in Worldwide Telescope, you have a copy of the data that you're looking at. So that data goes in. It's in a special format that's native to Worldwide Telescope. It's called a Worldwide Telescope tour file. And then you can go ahead and install the Excel add-in, and as you do that, because the Excel add-in has the ability to talk to Worldwide Telescope, there's a back-and-forth data and metadata connection. So you can not only send data across, but you can actually pull data back into Excel. So that would be a way of, for example, recovering data that's embedded in a Worldwide Telescope tour to a format where you can manipulate it as you do in Excel. Once you have worked with Worldwide Telescope, the client, and created a tour, or you want to save one, you can save that to your computer as a standard WTT file. You can also save an Excel spreadsheet, a .xlsx spreadsheet file, or any other kind of file you like. You can save that on your computer, and then you can go ahead and upload that using the Publish button at the Layerscape website. So this is getting to the process you were describing earlier. Once you've gone to do the publishing, then here you are. And this is an example from one of our collaborators. This is the Arizona State Geological Survey. And they've gone to Layerscape, and they've actually created about, I think, 20 different tours because they're having a centennial in the state of Arizona this year. And to celebrate that, they've created these different tours for the different areas in Arizona. This one happens to be Saguaro National Park. And so there's some highlights about this slide that I wanted to point out. Oops, page down. The first highlight is that this is content that somebody else has published to the Layerscape website, and it's its own dedicated web page. So it has its own URL, and you can share that with somebody just like a URL, like any other URL. In fact, down here at the bottom, you can tweet about it. You can like it on Facebook. You can mail it to somebody. And that's the way that you could sort of get the message out that you have content here that you'd like somebody to look at. There's also an edit content feature here, so you can go to the upload page, basically, and modify any of the descriptive stuff that you've put in there, metadata and so forth. You can add icons, and you can modify the way that this content is presented at the Layerscape website. And then lastly, I'm just emphasizing that the author of this tour is called the Arizona Experience. That's a project name. And the category is Earth's surface, and the Arizona Experience is also the community to which this content belongs. So there's a community there that you can subscribe to. And that community feeds directly into the Worldwide Telescope client, so you can surf this kind of content from Worldwide Telescope in addition to surfing from the web. So there's a lot of interconnectivity here. It takes a while to get used to, but we hope that in an integrated way, it's all going to kind of coalesce and make a lot of sense the more you use the system. Okay. So with that, I want to take a break for just a couple minutes because I'm going to, my computer is being very uncooperative, so I'm just going to take a couple minutes to reboot it, so I apologize for that, but then I'll just start right up on talking again after I bring it back up. Okay, that's a good sign. So I'm going to go up to Pacific Northwest and do the next sort of thing in the hit parade here, which is to give an example of loading a map. So you'll notice that we have a layer manager over on the left-hand side. The layer manager is expandable. There's an Earth layer, which has the International Space Station turned off and the moon turned on. But in this particular mode, this is the look at the Earth mode. The moon's out of the picture. All we have is really the Earth to work with. And then I went to the state of Washington has a Coastal Atlas website that has a bunch of different layers available. And I made a map there. And let's say that I have some data that I want to view here, and I want to view it in the context of what's on that special map. So I'm going to right-click on the Earth. And in general, if you end up diving into Worldwide Telescope, the right-clicking on different entities, be they tour slides or layers, is the sort of key to the whole process because it gives you this big, huge pop-up menu. So I'm going to add, and I happen to have a map sitting here. So fantastic. I have a map, and it's showing up here on the Earth. So I'll back away. Obviously, my map of Puget Sound is a little bit too big, but it's got the central crosshair that I can use to move it around, and then it has corners that I can use to resize it. So I'm going to bring it down into Puget Sound, and it's going to mostly work, but it's not going to work perfectly. And so when it doesn't work perfectly, then I'll outline the idea of how I can make it work much more perfectly. So again, zooming in recursively, sort of shrinking the map to fit the right size, make it to be the right size. We're coming down here into the South Puget Sound, and you'll notice that this island here, Anderson Island, matches that Anderson Island there. So that's my destination, my target. I make them about the right size. And then I lay it over the top, and behold, we now have a map that's sitting on top of Worldwide Telescope, background imagery and background topography. But it's not a perfect match. I'd like to do a little better. So again, I do this right-click business. I'm going to go ahead and right-click on the map layer, and you'll notice that there's an opacity option. So I choose the opacity, and that gives me a little slider. And I'm going to slide that down so that my overlay map is almost transparent enough that I can see through to the background. So there's the background, there's the foreground. I'm going to fade that down to like 25%. And now my map is something I can see through. Okay, so I can line this up. I can take, I'm using the upper left to sort of place the thing. Then I'm going to grab the right corner here and move that little tiny island on top of the real tiny island, and so forth. So I can stretch this, move it around from the corners. And eventually I'll be sort of fairly happy with the match that I've got. So when I'm done, I'll say OK. And now I'm going to zoom down and see how I did on Anderson Island itself. Well, I'm a little bit off. So if I fix the corners, then Anderson Island is off. If I fix this part of Anderson Island, then the other side might be a little distorted. So there's a little bit of map distortion there. So the answer to this, well, there's a lot of different approaches you can take to this. You can reproject if you're a GIS expert. But there's a sort of a cheating method that you can use too, which is that MSR, Microsoft Research, has produced a tool called Map Cruncher. And Map Cruncher, you can just search for that. It's all one word on the web. And I'll also make all the stuff that I talk about here available through Layerscape and through Yen at the end of this workshop. So Map Cruncher allows you to load up an image and then side by side compare that with Bing Maps. And you can zoom down and zoom back and move across, and you put push pins into your own map and into Bing Maps by using a crosshair. And by doing that, you can co-register two maps. And it turns out that Worldwide Telescope is using the same map projection as Bing Maps, so that if you register something to Bing, you sort of get it for free in Worldwide Telescope. OK, so that's the overview of how to bring something in. And then when I'm done, I'm going to sort of demonstrate that I do, in fact, have topography draping going on here. So you can see the contours of Anderson Island, these cliffs here, and sure enough, we're draped over it. I can decide, well, OK, I'd like to be able to make this a little bit more opaque in sort of my final viewing of this thing. So now I've made it more opaque, but I can still see some features through Anderson Island. And so now I've got this kind of mashup map, and now I can bring in some data on top of that and so forth. So let's go ahead and real quick make a tour. We'll call it AA. And we'll save that tour, and I'll sort of show you the process of publishing them. So we'll say, OK, here, let's add a new slide to the tour. And this is what I did yesterday. So this tour is now one slide long. And I'll move down here to look at Ketchikan Island. And I'll make that by right-clicking again the end camera position for this slide. And then I'm just going to add another slide. And pull back out. And set the end camera position here. There's lots of little subtle things about the tour authoring environment. For example, if I click on the duration of a slide, which is currently 10 seconds, and use the down arrow, I can make the slide much shorter. So the transition will happen a lot faster. OK, so now I'm going to save this tour to my desktop. Call it test. Save. And I'll play the tour to make sure that it works properly. Sure enough, I start up looking like this. I go down. We'll pan around Anderson Island. And then there's that fast second slide that brings me to my end point. So that's the whole tour authoring process. Now I'll bring up Internet Explorer, and I'll publish this tour to Layerscape. So it recognizes me. I've already logged in using my Windows Live ID. Click Publish. I'll browse to the file. I think we called it AA. Or we called it Test, you're right. Open. Fairly small file, so it should upload pretty quickly. So this is kind of what I would call the manual aspect of using Worldwide Telescope. Okay, so that's using the interface, the Worldwide Telescope interface, to grab data. And you can add in stuff like shapefiles. It's not a robust support for all shapefiles, but if you have shapefiles, it's straightforward to give it a try and see if you can import them into Worldwide Telescope. And then you can incorporate them into a tour. The idea is that if you had an army of people working on it, you could sort of anticipate all possible file types, and you could write importers for them. And since we don't have an army of people, we don't have a lot of a development team working on this 24/7. Looks like it's sort of not happy about the upload process. Because we don't have this army of people working on it, we look for tools and ways of doing the import process that make sense that can solve a particular collaborator's problems. And so, for example, we're working on coming up with a good way of getting a netCDF file in, because netCDF is a common currency. Okay, so it's giving me a hard time about the upload. It seems to be my data have a bad demo experience, so I'm just going to not worry about that. But you can see where the file would appear here in this form, and then I can go down through the rest of the form, and I can expand the metadata and type in who the author is, what the tour is about, and give credit for the data, cite the data source. What the heck with that? Okay, so let's see. The next thing that I wanted to do was talk about the Excel add-in. Let me bring back, actually let me bring up PowerPoint. I mentioned that we're trying to put how-to content into the Layerscape website. And so this is our home page. And down at the bottom, there's this how-to icon. And this is attached to something called Layerscape Workshop Tutorial A. So that's a PowerPoint deck that's at the Layerscape website. So like any other file, you can just pull it off the website and open it. And so I've done that here. This is the deck, and it's about 42 slides. So let's go through them all. Actually, I don't want to go through them all. I want to just sort of go through them at high speed so you'd get an idea of what you would be doing if you sat down with it for an hour or two and went through this deck. So first I talk about the motivation, and then I describe how the process goes. I say that we're assuming you have Worldwide Telescope and the Excel add-in installed, that you've got sort of familiar with Worldwide Telescope. It talks about where the website is, and then it goes through a set of steps to set up your data. So this is basically data manufacturing, synthetic data in Excel. And all I did was create some columns, some formulas. And I ended up with, let's see if it shows it fairly clearly. It's not really clear here, but I'll try Dan's trick with the plus. I'm going to regret this, eh? That kind of works. Okay, so I created some data, and there's a latitude, a longitude, an altitude, a color, a magnitude, and a start date and an end date. This is all in this tutorial that you would run through if you really wanted to get into the nuts and bolts of how to do this stuff. And once I've done that, once I've created that data, then the next steps we have are to import the data into Worldwide Telescope. So we're going through the steps. Again, I'm not going to belabor them. But once it's in there, then you've got to go and play the data back and explore it. So let me see if I can do that real quick, as I have a couple minutes left. Windows done. Okay, I'll turn off the magnifier. Turn on Excel. Maybe my computer needs to go on a vacation. It's kind of ridiculous. All right. So what I was going to do there was open up the Excel file and push the data across. But as it happens, I also would like to talk about the API for the Worldwide Telescope. So I'm going to move on to that. We'll see how that goes. So I notice I have a project here called WWT API project. So I'm opening up Visual Studio. And if you're not familiar with Visual Studio, I happen to like it a lot as a development environment. And I have a design page here that shows what my little WinForms widget's going to look like. So I have 4 buttons. They're called, I haven't made the font big enough, but they're called Halt, Gen, Send, Get, Elevation, and Maneuver. So Get Elevation is not active. Halt just stops the program. But Gen, Send, and Maneuver, I'll talk about those, okay? So the first thing I'll do is compile this program, see if that works. Okay, so now I have a compiled version of the program running here. And I have Worldwide Telescope. So life could not be better right now. And I'm going to click on the maneuver button. And all I did in this maneuver button, I'll show you the code in a second, but I sent a command to Worldwide Telescope saying, please send me to this latitude, this longitude, this zoom distance from the Earth. And then I also give it an azimuth angle and a look angle. So if you're looking in your default attitude in Worldwide Telescope, you're looking straight down at the ground, right, which is the nadir view. And that point that you're looking at on the surface of the Earth is called the surface reference point. And as you maneuver around, your surface reference point is moving. But you can also change your perspective relative to the SRP nadir vector by tilting this way. So I can, if I'm looking straight down, I can step back, and now my nadir angle is, or sorry, my look angle is changing from 0 to something like this. And then I can also walk around my surface reference point at an angle here. So all I did was send one API call to Worldwide Telescope. We'll find out if it works. Amazing. All right, well, I hate to sound like I'm really down on my computer, but I'm going to have to blame this on my computer. And you can... Yes? Yes, there is. The question is there documentation for the API online? In addition to the code that I can show you here. And by the way, I'm going to be publishing this. As I mentioned, all this content will get published at Layerscape. The API is available through, let me see if I can show you. I think the API is available through an older Worldwide Telescope link. So I'll type in worldwidetelescope.org. You find it? Okay. Right, under resources. Okay, good. So that's that. And the last thing I'll do, because I'm running out of time, is just to talk about some of the code here, again using the sort of the plus button. So okay, good, 300%. All I wanted to say in this section is that I have a command up here at the top of the screen. You can see that, which is URL equals string.format. So all I'm doing is taking a string called URL, and I'm writing into it a URL, of all things. The 0 argument is a loopback host IP address. And then you see colon 5050. And that's the sort of key to talking to Worldwide Telescope, is it listens on port 5050. So right now I'm writing this in C#. But if you're interested in talking to Worldwide Telescope, which, you know, on a nice reliable computer, then you can do this using any programming language you happen to be fond of, a scripting language. We've seen it done in MATLAB, for example. And all you're doing is basically creating this print statement, and then the second string here, second command is response equals client.upload string. That's passing that URL. And you'll notice it's also passing a second, right where my cursor is, it's passing a second blank string because there is no data payload when you're telling Worldwide Telescope to maneuver its perspective over to this other part of the Earth. So the rest of this URL is just command equals set properties, and then it says, sorry, I'm getting confused here. Perspective. There we go. Okay. Command equals update, and it's instantly flying to these 5 parameters, and there's the 5 parameters: the latitude, longitude, a zoom value, an azimuth, and a look angle. So when this is working beautifully, which for me it actually usually does, it's a little disappointing it's not working right now, but there you go. This will just simply jump you to the perspective that you're trying to get to. Okay, and then the last thing I'll talk about, just to bring this thing to a close, is that we have a set of really just sort of one command up here. This line says layer ID is equal to the API.createEarthLayer, and then it gives a string here which is going to be the name of the layer in the layer manager. And then it gives it a series of parameters that are separated by tabs. And the first one is a all caps geometry, and then a start date and an end date and a color. So this is the initialization of a layer in Worldwide Telescope. So underneath the Earth, because I'm going to attach this thing, it says create Earth layer, and I'm going to attach to the Earth a data layer called random walk. And that data layer is going to have associated with it, it's going to register a parameter sequence. Okay? So the parameter sequence here is exactly up at the top, separated by tabs, geometry, start date, end date, and color. So that when I subsequently format a data string, I'm going to be filling in that data string with those 4 sequences, one after another. And when I send that second command, that's going to be a data payload, so it'll no longer be a blank string. It'll be the full data payload. That's going to go to Worldwide Telescope, and that data is going to sit in the Worldwide Telescope engine. And it's going to be associated with time series, and so that I'll be able to play that data back. Okay. So that's the creation of the layer, and then the rest of this code here is just a little loop that goes through, and it builds S is a string that I'm going to end up sending. So down here I update the layer data by passing the string version of this little variable S, and S is built by these sequence of appends. So I'm just building a print statement, and this is the data payload that I'm going to be sending. Okay, so you'll notice that here it has this what's called a line string, if you're familiar with well-known text, and that's so that I can send a series of line segments that are all connected together. And so in the previous demos that I was doing earlier, when everything was working beautifully, if you saw lines that were being drawn, it's just simply using this well-known text line string in 3 dimensions. And then, of course, it has a time tag. Okay. So I'm just going to try it one more time, and I'm expecting that it won't work for me, alas. Well, you never can tell. Okay, so there's the Earth. And no, it's not going to work. Okay. Well, I'm going to call it good there, and I apologize again for the demo's not working, but sometimes this happens, and I'll have to figure out what the deal is. Basically, what you've seen now is me talking at length without any sort of substantive evidence to back it up about how this works, but we did get to see yesterday the end result of all the stuff that I'm talking about here. So again, I'll have to sort of follow back with you on the references and the material here after this workshop. I'm here the rest of today and tomorrow. I'll probably get it working, so if you are really, really keen to see this stuff working, come and bug me, and we'll sit down and we'll sort of do some of the stuff that wasn't working here once I get everything back in order. So at this point, I just want to ask, are there any questions about this stuff that you have? And other than that, I'm all set. I'm all done. Yes. A YouTube video from a tour? So one of the things that's built into Worldwide Telescope is a frame writer, so you can write frames. But basically, Worldwide Telescope, the design team that built it, which is not me so much, they have not built in a video capture functionality. So what you can do is you can run a tour and you can capture it with using something like Camtasia or Expression Encoder, I think is something that comes with Windows. So those are sort of methods that you can use. But if you've heard of Camtasia, that's one way of doing it. Yeah, that's basically the best. Yes? When will NetCDF support become available? Basically, what I'm trying to do is I'm trying to put together a set of tools that will work outside of the Worldwide Telescope client that will translate it into the Worldwide Telescope. So I don't have a date for that right now. I don't have a concrete roadmap. It's a piece of engineering that would be really great to get working because NetCDF is sort of the lingua franca of big data sets. So if you or anybody is interested in talking to us about that, then that would be a really great thing to embark on. Yeah. Let's see, anything else? Okay, cool. Again, apologies it didn't work beautifully, but I will be here and happy to run it back once it is working. I'll have Yen mention that it's working again. Thank you. So kind. I wonder if it's the Wi-Fi. Yeah, so the question is, if you download a tour, can you extract the information? You can actually use the Excel add-in to pull, to talk to Worldwide Telescope, see what the layers are, identify the data layer that you're interested in, and inhale that back into Excel, into a table. Yeah.
Okay, so John Willson, ITM actually, Alberta Environment and Water. Couple of things about this. As you do science and that kind of thing, you'll notice that I'm just one member of a large number of people that have been involved with doing open data in terms of the department. Just want to cover off three things. First is a little bit of scene setting, because you need to know where we're coming from in order to see how we got where we got. Our use of open data at the moment, okay, and our future use of open data. In terms of the future itself, we're in the middle of a provincial election. What that means is that everything we talk about in the future could well be vaporware. So if you just bear with me, but we have budgeted it and we have gone along with it. Many of you might not know that Alberta is home to the oil sands, and the recent Keystone Pipeline project that was delayed by President Obama was taking oil from those particular oil sands into refineries in Texas. We already provide, as a country and as a province, we already provide about 20% of the American oil that's consumed in the United States now. So this was additional oil that was being provided, and we already do cross the borders. Okay, so it's all that's saying is it's topical. Okay, in terms of where it fits in scene setting, show some websites here in a minute, but in terms of it, last year, okay, MS Research published environmental informatics framework. We're following that framework. Okay, so we're walking right down through it. We have all the problems enumerated there, and we're using open data to solve some of those problems. A year ago also, open data was used to pull down the EPA data for the BP oil spill, and driven all the way through in terms of its capabilities. So that struck us as pretty apropos in our particular case. Now, why open data, that kind of thing? Open data requires a whole bunch of things, but ultimately open science and open government. In our particular case, we have an enterprise data warehouse. Okay, we have open results that we're trying to present. This right here is a functional decomposition of some hydrological models that are desktop. So it's re-engineering hydrological models to be cloud-based as opposed to desktop-based. So we've created a service resources module with a UI, service composition module so people can choose them. And we've got a whole bunch of SSIS, of course. In our particular case, having done this, we looked at how it applied. So in our case, we have open data, open results, open models, open science, and our data stack consists not only of raw data, but raw data with gap fill-in, and then GIS-enabled data, and then modeling data itself. Okay, so we actually have a data stack in which we identify the raw numbers, and those of you that have done modeling know that one of the hardest things to do is gap fill-in, because there are multiple ways of filling in gaps in data. We have data, hydrological data, going back to 1893. So what's happened to a monitoring station since 1893? Well, it's been flooded out, it's gone downriver. There's all kinds of things that have happened. So to fill in that gap, which was cleverly gone over yesterday by Alex in terms of open data, he just put in zeros, okay, or nulls. But it could be blanks, it could be zero, it could be null. You have to have a conscious decision to take raw data to make it actual data. And that conscious decision is a very important thing for us in terms of the use of OData. It's so important for us, we actually have what we call data sharing agreements with our business units. We don't publish data unless we have agreements on how that gap was filled in and how accurate that data is. So for instance, some of our SSIS transformational packages use things like regex and that kind of stuff so that we don't have monitoring stations in other countries. We only accept data that we know passes reasonableness checks in our particular case. That's an important thing to note. We're TFS, or TFS SQL Server 2008 R2, Visual Studio 2010, and JSON. But all of this, it's our intent at some point to actually put our models out and people can run the models themselves. So along with the open data, the open results, the open models, definitions of how we made our judgments with respect to our data, we're about as open as you can be. You might ask, why are we being this open? It's a data integrity issue. And I'll be walking down through some of the things that we have right at the moment. In particular, we have something called the Oil Sands Information Portal. And it has a large amount of data sets in it. Roughly half a terabyte of data. And remember, this data has been approved, sanitized, judgment embedded in terms of gap fill-in. We have another farm of SQL Server databases for GIS data. So along with the Oil Sands Information Portal, we have GeoDiscovery Alberta and a lot of things that are in there. Those of you that are hydrologists, we have Arc Hydro with pour points throughout the whole province. So all our watersheds and sub-watersheds are there. We have other portals, and I'll show you some of that. We actually, much of the data in our enterprise data warehouse in the OSIP portal is, well, it could be in some cases as old as a month or so. But we do have real-time air quality monitoring that's every 5 minutes. Okay, so that's another portal, and we show you that portal. What you see here is a one-stop portal. The government itself liked the idea of open data so much that they're generalizing it across the whole government. So just like the government of the United States has data.gov as its primary portal, and just as UK has data.gov.uk, we're intending to have data.alberta.ca as a portal. Now, it's an interesting portal in that it's a portal that the average person would use. Okay? It's a portal built in a certain way. It's called a federated distributed model. Okay, so up here you have on door opening certain kinds of data sets, say the top 10 popular data sets that are pulled off of the OSIP portal. Those of you that are environmentally well aware know that we have well, rendering ponds or ponds in which some birds have landed, unfortunately, quite badly. We have all sorts of issues going on here. We've had people visit these oil sands from all over the world. And there are some pieces of information that would be popular globally. And so they'll be up there in terms of the standard. This one is presently under construction. It's Drupal. Most of you might not know Drupal.org, but I'll show it to you in a minute. The interesting thing about Drupal is that it is OData compliant also, which means that we'll be able to talk back and forth. We create a separate user class of people similar to yourself, such as researchers or academics or people that want more extensive data capabilities. And one of the nice things that Rob did is he actually took some of our reclamation data and put it on the Worldwide Telescope for us. So, so we now have, and we'll probably be going that way ourselves with respect to that. So let's see if I can get to my websites, and I don't see them. Okay, so I mentioned earlier open data for open science, and in terms of open data for open science, just want to go down here and just want to try something and see whether or not this actually works. It did. How about that? Okay, so this is the environmental informatics framework. You can get it right off of the website for this particular location. If you want to see how to do open data, last year had open data tutorials. This particular tutorial is in Visual Studio, walks all the way down through from capturing EPA data. And I'll just pull up the EPA website here. And it's not going to come up, so we'll just have to see whether or not I can get it a different way. Let's just see if it'll come up here. The important thing about the EPA website that was used last time is that yes, this is what I was expecting in terms of it, so just bear with me. You've all gone through this process. It just means that one of you's kicked me off. Not that there's anything wrong with that, right? It's probably just a measure of my... let's hope I get in there. Okay, and it should come in... Okay, why I wanted to show the EPA download is this is what went into last year's Visual Studio in terms of the BP oil spill. And it's taking a while to load up, so I guess there's some issues associated with what's going on here. Yeah, I'll ignore it in a minute. Okay, so, all I wanted to show here, and just keep this in mind, those of you that have tried to build different kinds of things on the web will know that SQL is a big, important part of some of the things that you're retrieving, because a lot of the data that you're retrieving from databases are relational. Okay, each of these fields, these drop-downs, okay, actually create an item in your where clause. That's an important issue when you start to look at OData. OData itself has the ability to carry these kind of where clauses in it automatically. Hey, that's important to us because we don't want the average user doing this. In your particular case, I suspect that there's a lot of coding. I don't know if anybody from the EPA is here, but I suspect there's a lot of coding making sure that SQL injection attacks don't occur. Okay, because it's going to have to be on a field-by-field basis, whereas if it was part of the protocol, that wouldn't be a particularly big issue. Now, here's my commercial. I have to give a commercial because I'm working for the government of Alberta. Okay, in terms of it, we produce on an annual basis something called the Statement of the Environment. Okay, the Statement of the Environment annually is how the environment is in terms of air, land, waste, water. So we produce this, and it's part of the data that people would actually want to know because we're making judgments in these particular silos of information scientifically. Now, why that's important is this state of environment is how we measure ourselves. Okay, so for instance, we could have shown some of the things that were shown earlier with respect to the Bing maps in terms of carbon footprint. We know ourselves that our carbon footprint's actually been going down, even though it's still not where it should be. Okay. However, we do know that other gases that many folks might not like, such as H2S, is actually going up and spiking, which is a terrible thing for the environment. Okay, so state of the environment, that kind of good stuff. We do monitor it. We do it. Okay, this is the OSIP information portal. Couple of things. Remember, this has already got a data sharing agreement. We actually give you a disclaimer when you come in. Yesterday, people talked about licensing and that kind of stuff. Derivative uses of the data are perfectly allowed, okay, but the derivative uses of the data, we're not going to guarantee, okay, perseverance, I guess, of the data other than the historical data. We divide it into two ways. We have it as a map view, and we'll look at the map view. Just click this off. Okay, in terms of it, we have our oil sands projects. We have climate change data. We have water. Okay, we have land distribution reclamation. We have air. We have biodiversity. We have tailings ponds and that kind of good stuff. Tailings ponds, of course, are where the poor ducks landed. Okay, one of the things we had to do in our particular case, this is an Esri rendered GIS, okay, is we actually had to invent these little oil sand plant icons, and we had to invent a little bit of our own vocabulary because at the time we got there weren't any. And you'll notice that it's very drillable, okay, and you can go right down to particular areas. You'll also notice that we can look at things that related to, in this particular case, tailings ponds, reclamation areas, okay, and you can view this in multiple ways. Okay, so nothing unusual about that, except that, again, you can drill down as much as you want and actually see it. And quite often when people are flying over it in helicopters in these areas, they'll actually be pulling down this kind of data in order to see what's occurring. Now, what does that consist of? Well, underneath it, we have a fair number of data sets. We, as I said, have roughly 1/3 of the known oil reserves, okay, and they're actually in 3 locations. Okay, they're in the Athabasca oil sands, the Cold Lake oil sands, and the Peace River oil sands, and we record our data, of course, in air, climate change, land, all of the things that you've seen reported on. So in our particular case, we have, as I said, a lot of data up there, okay, but right now we don't have our data in the format that would be OData compliant. We're moving it into XML as we go. Now, one of the things that we found is we had very average people quite often pulling down the data. the average people pulling down the data had no context to understand the data that they were seeing. So we actually do a wrapper, not a metadata wrapper, but a scientific wrapper of what it means to view the data. And then, of course, you could actually pull down the data sets yourself and play with them if you want. And you'll notice in our particular case that we're running, you know, CFVs and PDFs and that kind of stuff. Yeah, if it completed, where'd it put it? So the data, okay? Not quite compliant yet to OData standards, but it's getting there. Okay, one of the things I skipped over was Drupal. Okay, Drupal's homepage, all these URLs are at the back of the presentation, so you can click on them. You don't have to record them per se. But Drupal itself is a website builder, I guess, that's OData compliant. And although we presently have it in 3 or 4 locations in Alberta, we have it at the City of Edmonton, the City of Medicine Hat, and soon to have it within the government proper. It's not our particular website of choice right at the moment. Okay, what else do I want to show? Okay, so we talked about that. Okay, the other thing we have, and this will take a while to load, this is another catalog of data, and this particular catalog of data is GeoDiscovery Alberta. And again, it's an Esri loaded model as opposed to a KML, okay, or as opposed to, I guess, really some of the others. Again, you can render, you can drill down, and it's actually the engine underneath all the other ones you've seen. Again, it has a massive amount of information itself, and just put it up there so you can have a look. Almost all our hydrological data is on there, almost all of our weather type data, almost all of our atmospheric data. So this is us protecting ourselves. We take data from other sources, and in terms of it, we have a regular disclaimer, but this is a real-time map of the air quality in Alberta right now, being updated in every 5 minutes or so. Those of you that probably aren't aware of it, these are air measuring stations, and there are 3 that we have in the area that you just saw, something like 40 oil sands plants. So think about that. So we're making a strong effort to add a lot more monitoring stations. Okay, when years ago I did one of the first hydrological model simulations of the Peace Athabasca Delta region, and we had 7 monitoring stations, some with data that went back to 1840. Okay, so one of the things that we now have is 43 watering stations. And the question is how do you have, or how do you know whether or not you've got a hydrological model that actually maps back to the data that you have? Well, you have to do post-diction. You actually have to have predicted the past successfully in order to know that you can predict the future with some degree of confidence. Okay, so back to earlier I mentioned gap fill-in. That's why you have to know what the data is in the past, or how you made your judgments in the past, in order to know whether or not you post-dicted correctly. So in this particular area, this is the Fort McMurray area, and I think earlier, this is not coming up, but it's a good day to breathe in Fort McMurray. Okay, it's 1 low risk, today's 2, maximum forecast. Okay, and as I said, because we're dealing with average folk, we have a whole mass of information that can come up whenever you see data. So we have a lot of hyperlinking going on in our particular case in terms of looking at data in one situation or the other. Okay, so we close this down. See if we can find somewhere where it's not good to breathe. It's a good day. We had some 6s here the other day. Real time, updated every 5 minutes. What else? Okay. This is what the UK government's using, and they're actually, this is data.gov.uk, and they're using a system from something called Paulus, as opposed to data.gov in the United States, which is using one called Socratic. Okay, so there's a whole bunch of websites and their relevance and that kind of stuff. So what are we doing with OData? Well, we've got the one-stop portal. It's OData compliant. We're actually driving OData across all of our underlying infrastructure. This and this are SQL Server farms. This is an Oracle farm. Okay, we actually got software now that's pulling data out of the Oracle legacy systems, or out of the Oracle legacy systems. Missing from here is proprietary systems. We're actually now trying to pull data. Those of you that are hydrologists will know whiskey as a particular package. We're trying to pull data from whiskey. So why do we use it? Allows SQL across data silos. Okay, it's embedded within the protocol itself. Very nice feature. Okay, follows internet standards. You've heard today a whole bunch about HTML5. Why would you want to do HTML5? OData is completely compliant with HTML5. Okay, and uses it. Has its own data access APIs if you need them. One of the biggest things for us is bring your own device. It's agnostic with respect to the devices. So we have some of these devices already working. What you see with the arrows, we already have working, and in our user acceptance test in place. The way in which I think of OData is I think of it as ODBC, okay, for the internet. If you have data pools, okay, it's really nice to be able to go against those data pools. Okay, and as long as everybody plays nice with respect to the protocol, it's a very easy thing to code and work your way through. In our particular case, we have to do a bit of retrofit. You've seen that we've been using Esri. Okay, in a lot of places, we actually want to produce KML. You saw KML with our air quality index that's produced daily. Like people don't understand sometimes the advantage of the air quality index. Just a war story from the past. We used to have 800 housewives at 8 o'clock in the morning go out and sniff the air and tell us what it was like. Okay, now we have little sensors that sniff the air for us, and it's pretty good. Okay, what else? We're, in our particular case, moving everything into XML as an initial start. We're just relatively new to the OData phenomena. And as I said, we actually followed a whole bunch of stuff that was in this conference to begin with a year ago. And this is one of their slides. All the stuff that you see here that's very, very web-like, okay, but very difficult. We had individual coding of a bunch of different places to get data sets. Okay? By going with OData, if my mouse works, okay, this gets cleaned up and very understandable. Okay? What happens is, although we're using Team Foundation services to capture and control the software, okay, you have way less software. So it's not it's instead of having large number of a package for this and a package for that and a package here and a package there, here a package, everywhere a package. Okay, you have a situation where you can control it a lot better. I talked about the air quality index. We, of course, independent of what we produced, have a large number of other data sets that we just haven't published yet. And you might say, well, isn't that going against the open data concept? Okay, we don't like to publish crap. So we spend a lot of time making sure that the data is as accurate as we can get it. Okay, and that it's scientifically valid. And so we have a whole range in our catalog of data in different positions. We've actually had data submitted that was 70% in error. Okay, we actually had to work with the business community and come back and say, how can you even produce this? Okay, and that's just the nature of the beast. Now I have a whole bunch of things, and I got 4 minutes. I just want to leave you with one concept. Okay, the concept is putting picture puzzles. Anybody here not done a picture puzzle before? You know, where you put little puzzle pieces together? Okay, there's a concept associated with that. Okay, in our case, it's air, land, water, biodiversity. The standard way of doing it is to look for something that's in the other dimension. So if it's a three-dimensional puzzle, okay, you look for the piece that's three-dimensional. If it's a two-dimensional puzzle, you start looking for the corners and the edges. Okay, and that's top-down. Okay, now you might say, does that work? Well, it works really well if you have a rigorously defined organization. Okay, if you have a command sort of structure. Okay, progress is top-down and that kind of stuff. But most of us don't work in a top-down structure. Most of us work in a distributed type structure. And there is an alternative way. And this is how our portals were built. Okay, we actually got everything associated with the land. Everything associated with the air. Everything associated with the water. And we're working out towards the corners and towards the sides. Is one better than the other? They both get the same result. The puzzle gets put. Now this one's pretty tough to conceive of, but one of its major advantages is you make progress every time you put another piece of the puzzle. Okay? You might not have agreement as to what the borders are or what the corners are, but you can certainly get agreement on the puzzle. We right now have 0.5 terabyte of data where everybody's agreed on the puzzle. Okay, where people have actually made individual decisions, okay, on very small pieces and put them together. And that's it for me. There'll be more slides. But I'm passionate about this if it didn't come across. Okay, so OData is, we're looking to it as one of our saviors. Thank you.
So, John, thank you so much. Any questions for John?
Wonderful job of obviously bringing this extremely large data set, curating it, and providing it. And on this, looks like on the process side also, the workflows, you got some things in place. But given the multiple tool sets that are typically in a government organization, the Esri products and Google and Bing Maps, and each one their strengths and things, how are you creating a comprehensive set of tools that strategically would provide consumer access at low cost versus being an enterprise kind of tool?
I really like the question. The question is what's the trade-off in terms of development on the tool set? We had a major effort 4 years ago to go with Oracle and Oracle BI tools and Oracle this, that, and the other. We couldn't get agreement on the corners. Couldn't get agreement on the sides. So what we did is we funded a very low-cost Microsoft-based Visual Studio approach, and we went with these pieces. Instead of using an Enman enterprise data warehouse, we used the Kindle data warehouse. Okay, we just got a couple of pieces together and just kept building the pieces. Then we could show people the sky, and then we could show people, and so we could get buy-in a little piece at a time. So now we have buy-in where we're almost at the edges now, and a lot of folks are actually trying to go on the bandwagon. These things are all up there. You can use them. You just won't see the OData because the OData is in the user acceptance testing area with us. We're just new to the process. But we'll have OData completely into the government portal relatively quickly because in our particular case, the department wants to retain its department sovereignty in terms of its direction, and so doesn't want necessarily overall government portal because we do a lot of science, and you know, most of the government, they do a lot of accounting. So there are some things that we have to share and give up, but we don't want to give up the science. So the trade-off is probably about 5 to 1. We never did in 4 years get the Oracle approach working.
More questions? And when the first time that Alex James, our OData collaborator at Microsoft, presented OData 2 years ago at the eScience workshop, he got no question and then no conversation. So today you got a good question, right?
I got a question.
And, yeah. So we're going to switch gears. How many of you have heard of something called Pivot Viewer from Microsoft? Oh, okay. Frank is from... stage of data mining flow so that you can focus on things that you're really looking for. And Frank has come up with a really innovative way to just to show you how you can play with any data at all, social media and any other things, with this pivot viewer.
This mic?
Take one of these, yeah.
Testing 1, 2, 2.
No?
Nada.
Is it on?
It's on. Test 1, 2, 3. How about now?
Switch
Okay.
this one. Oh,
Okay.
is it on?
I think we got it.
Maybe that's this one. Okay, cool.
Okay. Great. So my name is Frank Martinez. Work at Microsoft Research. Our team actually is responsible for building, managing the web platform for the division. So if you go to research.microsoft.com, you will see our work here. And instead of talking about Pivot, we're going to pretty much focus on 2 aspects, mainly the HTML space and OData.RMC, which is something that we built out last fall to get on the OData bandwagon. One of the things that's cool about OData is it allows us to give a semantic view of the data that we pour into our website. When you look at our website, it's really the result of what MSR staff worldwide are involved in, what they publish into our CMS, what we call RMCR. And what we have done over time is tried to find interesting ways to slice and dice the data that they publish to our web platform. One of the recent innovations in that regard is what we call the hub. And so what you see here is an example of semantic views on that CMS data. So you might have things like new people, or a new blog entry, or a new download, or a new publication, possibly a feature story, possibly a video. And this is all data-driven. There's nothing that's curated or editorially created on this page. So if I refresh, it'll go out to the platform and say, all right, now give me a refresh on each one of those particular asset types and load them into what we call the hub top end. So now let me switch gears for a minute. If you wanted a purely semantic view of this, this is where RMC OData comes in. And I'll just go straight into the FAQ, because this will sort of help you understand what's actually in our OData set that we derive out of the platform. Downloads, we generate a lot of downloads. When you look at Jan's team, there's a ton of downloads that team develops that will get pushed out to research.microsoft.com. Events, this is an event, but there's events going on year-round, worldwide. We'll also push those out. Groups, you have different groups working in different research areas, so you would see those. Labs, we're a worldwide organization. There's labs just about on all the major continents. You'll see those. Projects, there's different research groups working in different research areas. They spin up projects. Think of Layerscape, think of worldwide telescopes. Those started as a project. Publications, when you're a research division, obviously you're going to write a lot of papers, so you will see publications as another asset that's in the data set. Series is a little unique because it's our spin on a collection of videos. The video space is something that we've gotten into pretty heavily over the last few years, and you'll see a rather large investment in that space. But in order to organize those in a coherent way, we came up with the notion of series so that we could say, here's videos about TechFest, here's videos about an OData conference, et cetera, et cetera. Users, this is one of those anomalies that we actually talked to Alex about at our OData conference. When you look at the way the OData platform asks you to describe certain things, people is one that's a difficult particular element to try and describe. So as a default, we use users, but over time, we're probably going to rename this because we don't like that term. We don't like that use in the data set. But it was really the easiest way to think of how do you identify an element in the data set that represents a person, and then you would have multiples of the persons. Persons didn't really work. People sort of works in certain cases. We ended up with users. And then videos, as I mentioned before. So when you look at some sample queries, then you see things like being able to search across a different asset, being able to search across an asset with some substring filtering, being able to search across an asset with some other particular filter types built into it, or you could do relationships. Relationships are interesting. This is, again, the power of OData, is that you can represent relationships in the schema. So I could take this particular video, which we would call inside the platform 154.104, and I want to see all the speakers related to that video. You can bring back one person. That means there's only one person as a speaker related to the video, as opposed to, say, a session like today where you'd have multiple speakers. So that just gives you a general sense of what's in the data set. Highly recommend you go out, take a look for yourself, odata.research.microsoft.com. So while we were sitting back here, I decided, okay, let me spin up something really quick so we could actually take a look at how to use some of this. And so what I did was I built a basic little app that I parked up on Azure that gives you an idea of what you could do with this. So I'm going to go ahead and scrunch this down because I really wanted to build this for more of a mobile context. And the idea is pretty simple. I'm just going to create an HTML5 page, and inside of that HTML5 page, I'm going to build in some queries in the background. They're going to go to the OData set, return that OData set, transform it, use an XSL, pretty standard stuff, and then lay it out on the page. So the first one that I used was a search. So here I'm running a search against videos, so I can pick a term. Somebody throw me a term. Anything? Something? Astronomy. Astronomy. Okay? And I've got a selector here. I limited it to 5, 10, 15. I could change this to any amount, but just for the heck of it, I decided to do that. So we'll go ahead and click Go. And what we're doing is we are running out to the OData set. We are narrowing down by the video asset type, and we are looking for astronomy in the description and returning that. The cool thing about using OData that I'm really liking when you start to mess around with HTML5 apps is how fast it can return the data. You cache the data in your browser, you're ready to go. So that really opens up a nice world when you want a performance kind of experience. The other thing that we're noticing too, because our team builds phone apps, is when you leverage things like OData, leverage things like transforms against HTML5, you get a nice cross-device experience. So that means I could point you to this URL on your iPhone, on your Android phone, on a Windows phone, or anything that's got a pretty modern mobile browser on it, and you're going to get the same kind of experience that you see here. So let's go take a look at something else. In this case, I call this social. And this one is a preset query out to OData. It's a real-time query, but it's preset. But the difference here is that we included views, as you can see below the recorded date. One of the things that we're starting to do is to mine traffic to the site, classic web stats, how many page views, unique users, that sort of thing, and inject this into the OData set. So in this case, for this particular video, you have not only title, thumbnail of the video, duration, when it was recorded, but we also have how many views, at least since the last time we refreshed the OData set of that particular video. And what I expect us to do over time is to expand what we call that little social nugget. We might add things like likes, throw in a little Facebook angle, tweets against it. If there's any relationship to Twitter posts, tweets, we can put that in as well, but really start to build out kind of the social graph per asset that you return inside of the HTML5 app. Another thing that you can do, because it's built into the OData set, is narrow things down by a lab perspective. So in this case, I ran out of time to finish this, but what I probably could have done is push pinned on this Bing map different lab locations. In this case, I've hardwired to one particular query, which is the Redmond lab. So when I select this, what I'm doing is I'm, again, querying our OData set, and I am narrowing by labs, narrowing specifically by the Redmond lab, and then further by all projects for the Redmond lab. And again, very easy transform, really nice HTML5 layout. You can return. But this gives you a general idea of very quickly what you can build on top of this OData set. And the nice thing about it is as our site gets updated, going back to research.microsoft.com, and take a look here. As this gets updated, the OData set gets updated. So if you are a producer of apps, if you said, hey, this looks like a pretty cool data set, I'd love to go build some cool apps with the Microsoft Research OData set, you'll know that the data is pretty fresh. Every time we update the platform, i.e. new stuff goes to research.microsoft.com, you're going to see that mirrored over to the OData set. Okay. That's pretty much it. Any questions? And what? Exactly. Okay. Mm-hmm. That's a great idea. We haven't been that discreet in the design of that particular asset type events, but this is the kind of discussion we want to have to decide whether we want to start building that in so that we can start to form an ontology and really go beyond even events to start to think about ontologies when you think about, say, research areas. When you start to merge those things together, we have research areas in computer science, of course, but there could be research areas. I've heard some geo going on here that could blend into this. And working with Jan's team, it'd be awesome to get some of the geo data that we work with at MSR also into the OData set, because that would give us another opportunity to start to build out that ontology. Okay. Any other questions? Okay, great. Thanks a lot.